Hello everyone and welcome to this week's video. Today we are talking about outcomes and how they are defined in Simulx. Outcomes represent the post-processing of the simulation results performed per subject. They correspond to the measure of interest for each individual. Outcomes can be defined as different types, either as a numerical value, as a Boolean object, or as a time to event. The creation and post-processing of an outcome, therefore, allows to quantify and ultimately to interpret the output of a simulation. Here I have a PK/PD profile of a simulation, from which I want to calculate different measurements, such as Cmax, so the maximal concentration, and Tmax, the time of the maximal concentration. Regarding the PD profile, I'm interested in whether the response has decreased to less than 20% of its baseline value. For the first target, we will obtain a numerical outcome. In the second, the outcome shall be an event. And for the third one, we aim to get an outcome as a Boolean. In the Simulation tab, just below the Simulation panel, is the Outcomes and Endpoints panel. To create an outcome, I click on the plus and a window appears. Let me explain all the options available to define the post-processing that will generate the outcome. It starts with the naming. Next, the simulation output that will be post-processed must be selected. The values of the output can be modified in relation to a certain value using the options relative to. Let's look at them one by one in detail. The option relative to none does not cause any modification. The output profile remains unchanged. If you select relative to baseline with the option ratio, then the values of the original profile are divided by the first value. The division causes a rescaling of the values, which creates a new profile on which the post-processing will be based on. Note that in the new profile, the first point is excluded from the following output processing. The calculation of the change from baseline works analogously. Here, you select the option Difference. The baseline value is subtracted from each point of the original profile. Here too, the first value of the newly created profile is excluded from the following post-processing. You will see that these ratio or difference options are available for all the choices that are in the relative to list. Another possibility would be to divide the values of the original profile by the global maximum. Analogously, when calculating the difference to the maximum. Here, the maximum value is subtracted from the points in the original profile, whereby the range of values in the new profile shifts to the negative. The same principle applies if the minimum is chosen as the reference value. Here, all values of the original profile are divided by the minimum, or as here, the minimum is subtracted from all values. When calculating a new profile by dividing by the maximum value up to current time, the calculation refers to the minimum value that is re-evaluated per time step. The calculation looks as follows. At time point 1, a single value is available. This value is therefore the maximum value, so C0 is divided by C0. At time point 2, we already have two available values, C0 and C1. In this example, C1 is the maximum between these two values, therefore C1 is divided by C1. At each new point, the maximum must be re-identified. Here in this example, the profile peaks at the 6th time point, at C5. Therefore, all values that were in the increasing range in the original profile are equal 1 in the new profile, since they are divided by themselves. At the 7th time point, the maximum of the values C0 to C6 will be determined, which is still C5. Therefore, C6 is divided by C5, and this principle is carried on. To summarize, the value of the current time point is divided by the maximum up to this time and not by the global maximum in the profile. The calculation of the new profile based on the difference follows the same principle. The option minimum value up to current time follows the exact same logic as in the example before, except that instead of the maximum, the minimum is identified at the current time and taken as the reference value. Analogously for the difference. Last but not least, there is the possibility to select a fixed reference value with the custom value option. Again, either with the calculation of the ratio or the difference. After a form of profile modification has been selected, here we'll keep it to none. An element for output processing can be picked. Output processing will cause the calculation of a specific value in the profile for each individual. Once again, we have a variety of options. Let's look at them one by one in detail. If you select average value, the arithmetic mean of the corresponding profile is calculated for each subject. With first value per ID, the first available value of the profile per subject is determined. Analogously with last value per ID. With the option max per ID, the max value or the time of the max value can be determined. The time can be defined as a continuous value or as an event, which will impact the way it is represented in the results. The same applies to the option min per ID. With the selection duration below a value per ID, different options are available. Choosing cumulative time, the sum of the time intervals during which the output values meet a condition, is calculated. With percentage of total time, the cumulative time is divided by the total time given in percentage. Number of observations corresponds to the number of time points where the output values meet the condition. And time of the first occurrence determines the time point where the condition is satisfied for the first time. It can be continuous or an event. For the element duration above a value per ID, the same options as before are available. Duration between two values per ID is used to calculate the time span where the output remains between two given values. As before, the same options are available for this element. Finally, after selecting an output processing element, it is possible to apply a threshold value. For this, a value must be set and the relation sign must be selected. A logical test will be applied and we will obtain a Boolean object as an outcome instead of a continuous value. You see that Simulx offers a lot of flexibility to define simple or complex outcomes. Note that it would also be possible to define outcomes based on time-to-event output or to take occasions into account. I won't take the time to show this in this video, but for more information you can have a look at the Simulx documentation. Now that you have seen all the options, let me show you how I will use them to create my three outcomes Cmax, Tmax and threshold PD. The elements Cmax and Tmax can be created straightforward. Threshold PD, on the other hand, requires a modification on the original profile. Let me show you what this modification looks like before I show it to you in the interface. Here we see the profile of a subject with simulated data. We want to know if the minimum is less than 20% of the baseline value. So we set all values in the profile relative to baseline. This is equivalent to the question whether the minimum divided by the baseline value is less than 0.2. In this concrete example, the condition is met and we get the true outcome. Here too, we have a subject with simulated PD data, whereas the condition Cmin less than 20% of the baseline value, which is equivalent to Cmin divided by baseline is less than 0.2, is not fulfilled. Now we have all the tools we need to define the outcomes. I name the first outcome element Cmax. As output vector, I keep MLX-Y1, which corresponds to the output vector of the PK profile. I leave relative to as it is, and as output processing, I choose max per ID. I leave the option value of max, so I get a numerical value as an outcome. Finally, I click on OK. I name the second outcome Tmax. I use the same options as before, but now I don't choose max per ID, but time of max event. This way the Cmax is not interpreted as a numerical value, but as an event, and we obtain a time to event outcome. I click on OK. The third outcome I call threshold PD refers to the PD profile. Therefore, I choose as output vector MLXY2. As relative to, I now choose the baseline value, using the ratio to calculate the percentage change from baseline. We are interested in the minimum from the new percentage change from baseline. As a threshold, I set the strictly smaller relation sign and I enter the value 0.2, which corresponds to 20%. Thus, we obtain an outcome of the type Boolean. I click on OK. You can see here in the column next to the listed outcomes a column called endpoints. This column has been created automatically. Endpoints, the function, and how they are defined will be covered in detail in the next video. After the outcome definition is completed, we can select and execute the outcome endpoint task. We automatically arrive in the Plots tab and see the outcome distribution shown as a box plot of the first defined outcome, Cmax. In the distribution plot, Tmax, we see a Kaplan-Meier curve, and this is due to the fact that we have chosen the option time of max value as event. If I would have chosen as continuous, I would have obtained a box plot representing Tmax values. The distribution of the Boolean outcome threshold PD is visualized as a bar plot. We can see that 29 subjects have met the defined condition. Consequently, the remaining 21 subjects did not meet the condition, meaning their PD profiles have not decreased to at least 20% of their baseline value. In the Results tab, outcome results are located in the Endpoints section. The Outcomes Table tab contains the calculated outcomes per individual. On the top are the individual results of Cmax. The table contains the determined maximum value of each subject, followed by the Tmax table. In this table, for is event equal 1, we see the time at which Cmax has been detected. For example, ID 1 reaches its maximum concentration value at time 24. Below is the table of the outcome threshold PD. The table does not contain any numerical values as a result. The column threshold PD includes only true-false entries. These entries indicate whether the PD profiles decreased to at least 20% relative to the baseline value or not. The Outcomes Summary tab contains the corresponding summary tables of the outcome elements. Outcomes with continuous values such as Cmax are summarized using a typical descriptive statistics table. For elements that are interpreted as a time to event like Tmax, the median time is calculated. Boolean outcomes, such as threshold PD, are summarized using a frequency table, corresponding to the number of individuals with a true outcome and the number of individuals with a false outcome. I hope you learned something new today. Stay tuned for next week's video.